So now we're going to look at the last two examples on visual approach to limits. And in this first case, we're going to take in number 5. We're going to try and find the limit of f of x. And I didn't spell it out the last time, but f of x is just the function that's shown in the graph. We're going to take the limit of f of x as x approaches 2. So let's go back to our previous technique of drawing the vertical line through x equals 2. And then remember what it is that we're trying to do. We want to figure out what height you would expect to be at as you approach, as your x value approaches 2. So as we walk in this direction towards 2, and again as we walk in this direction towards 2. And I think in this case it's a little bit strange, but we can draw the little image of ourselves walking along the line. And we want to walk closer and closer towards that red line. So we're walking in this direction, and then this direction, and then this direction. And we can see that we're going to go down and down and down, and it's going to continue on forever and ever and ever. Now, when that happens, what we say is that we are walking towards negative infinity. We're tending towards negative infinity. So the limit as x approaches 2 is going to be negative infinity, and in that case of course we're walking in from the left, so we need to use our little minus sign. So it's going to be one-sided limits again, and as we approach 2 from the left, the height that we're tending to get towards is negative infinity. We can do something similar on the right hand side. If we take it from the right hand side, the limit of f of x as x approaches 2 from the right hand side. So imagine we're here and we're trying to walk towards that red line, and as we try and get closer and closer to the red line, what we find is we're going to have to climb up, 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 higher and higher and higher. In other words, we're going towards a height of positive infinity. In that case, you're tending towards 2 different heights. Okay, from the right hand side you're going towards positive infinity. From the left hand side you're going towards negative infinity. The one-side limits don't agree. One-sided limits don't agree, and therefore what we would have to say in that case is that the limit of f of x as x approaches 2, and again we drop the plus and minus now because we're talking about the overall limit. Once you have this condition that the one-sided limits don't agree, then the limit of f of x approaches 2 does not exist. So that's yet another case where the limit does not exist. So that's number 5, and then in number 6, what we have in number 6 is a graph that, oops, sorry, I lost it. A graph that oscillates indefinitely. Now this is the graph of f of x equals sine of 1 over x. Okay, and what we're going to try and do here is we're going to try and estimate the limit as x gets closer and closer to 0. And this is a very unusual case. It's not one that you want to worry about too much, but if you try and draw this on your own calculator, and then zoom in, keep your x max and y max, sorry, your y max and y min at -1 and +1, and then zoom in closer and closer along the x-axis, closer and closer to 0. You'll find out that the graph oscillates infinitely, just never actually settles down to one particular value. It oscillates infinitely. Again, this is an unusual case, not one to worry about too much, but when this happens, again, you say the limit of f of x as x approaches 0. Okay, we're taking the limit as x approaches 0, which is here in the middle. Let's draw the red line just to indicate that that's what we're worried about. That's where we're interested in. The limit of f of x approaches 0 excuse me, does not exist in this case. It's not something you're going to see an awful lot of. but it does happen in reality quite a lot. Now there's one other thing that's not on this graph, or not on this handout that you have, but it's important that you see it. And I want you to imagine if you had a graph that did something along these lines. Let's say we make this value 3. Okay, it can be anything at all, but let's say we make it 3. And we haven't seen one like this before. So let's say as the graph comes in from the left, it does that. And as you come back from the right, gone a little bit wavy, but it does that as well. Now in this case, let's try and figure out what the limit of f of x would be as x approaches 3. Okay, so we can start off taking the limit as x approaches from the left. So let's look at one-sided limits from the left. So as x approaches 3 from the left, you can tell that the graph is going higher and higher and higher, so the limit would be infinity. Okay, positive infinity, just to be clear, but infinity. Same thing. Same thing if we I'm having that surface trouble again. But if we come back this way from the right hand side, again the limit of f of x as x approaches 3 from the right hand side is equal to positive infinity. Okay, now this time, what's a little bit tricky about this is that the one-sided limits do agree with each other. Okay, so the one-sided limits agree. And when that's the case, it's perfectly fine to say the limit of f of x as x approaches 3 is equal to infinity. Now that is considered correct. Okay, that's considered correct. But there is an argument that's made. A limit has to be a number. It has to be an actual height. Infinity, as you know, isn't a number, and therefore it can't be a height. So what we can say also is that infinity is not a number. Okay? So it is equally correct to say that in this case the limit of f of x as x approaches 3 does not exist. Since infinity is not a number, you can say that the limit does not exist. The only thing that I want to point out here is the difference between this and the example that we looked at, the first example in this video, number 5. In this example, you can see, I'll just change the color of my pen here for a second. You can see that from the left and from the right, the graph headed up towards infinity, positive infinity. And when that happens, you can say that the limit is infinity, that's correct, but you can also say that the limit doesn't exist. Now let's go back to example 5. That's what we're looking at here. In example 5, the difference was that from the left hand side the graph went down to negative infinity. From the right hand side it went up to positive infinity. So those are two different heights. We don't have permission to say here that the limit is equal to positive or negative infinity. It's not, because it's two different heights. The only correct answer here is to say that the limit doesn't exist. Whereas in this last new example that I just added here at the end, because the graph is heading towards infinity from both sides, as you approach 3 from both sides, you have an option of saying that the limit is equal to infinity or that the limit does not exist. Okay, and I hope that, oops, sorry, scooting off on me again. I hope that is clear. If you have any questions, please ask about that in class. Okay, thank you very much.